How do you determine the uncertainty when the number of measurements is greater than 50? Here's the process. First, calculate the mean value. That means the average. Add everything up and divide by the total number of measurements. Then, calculate the deviations. That means that you subtract the mean from each measurement. Then you're going to calculate the squares of the deviations. Then you're going to add them up, and you're going to divide this by the number of trials. And finally, you're going to take the square root of the whole thing. So to do this, usually see it written with a formula. So this x sub I, that's the trial number I. So x sub 3 would be trial number 3, the third measurement. X bar, that's the mean value, and n is the number of trials. And so we get this formula right here, and you may have seen this before. This is the formula for the standard deviation. And in this case, this big thing here is a sigma. That means you're going to add up all of these quantities here. So what's this? Well, this x sub I, that's measurement number I, minus the mean value, this is just the deviation. And so then squaring it would be the deviation squared, and you're just adding up all of those terms from the first one up to the nth one, and you're dividing by the total, n. And finally, you're taking the square root of the whole thing. Incidentally, you might sometimes see this formula with an n minus 1 instead of an n down here on the bottom. It's probably not going to make that much difference overall whether you have an n or an n minus 1, but just be aware of that. Sometimes you'll see it written as an n minus 1. So in this case, what you're really doing is calculating the standard deviation. Let's look at an example. So here is the formula, and let's suppose that we have 15 trials. Now I know that you're supposed to be using this when you have measurements greater than 50, but remember that that's just a guideline. You don't have to do this for measurements greater than 50. It wouldn't be unheard of to do it with 30 measurements or even 15 measurements. It's just supposed to be a guideline to follow roughly, but you might see a different way of doing things. So in this case, I'm going to say 15 trials. Let's try and calculate the uncertainty using this formula. So here are 15 times. So we performed some experiment 15 times. Each time we recorded the time in seconds, and these are the values. So first thing we'll do, calculate the mean. So that's easy. You just add up all of the times, divide by 15, and if you do that, you get 15.4 seconds. Next, we're going to calculate the deviations. That means we're going to subtract the mean from each of the times. So for instance, if you look at the first row up here, we have a time of 16.1. We subtract the mean, 15.4, and we get 0.7. Notice that some of these deviations are negative. That's like this one here, 12.3 minus 15.4 gives us a negative 3.1. And that's okay because we're going to square the deviations. So you just take each of these numbers that we have for the deviation and you square it. Then we're going to add up the squares of the deviations. So if they're looking at this formula here, this is the deviation squared. This sigma here means add them all up and then divide by the total number of trials, in this case 15, and finally take the square root of the whole thing. And if you do this, we can say here's our mean again, x bar, and for sigma you would get 1.49 seconds. I don't know if I mentioned, but this symbol right here is a lowercase sigma, while this thing in here is an uppercase sigma. So this is the symbol that you sometimes see for standard deviation. So in this case, it's 1.49 seconds, so we would quote our measurement and uncertainty as 15.4 plus or minus 1.49 seconds. When you have a large number of trials, like 60, 70 trials, to do this by hand would be really cumbersome. But thankfully, there are plenty of computer programs or calculators that can do this for you. You can do this on Excel, you can do this with a TI something calculator. There's plenty of places where you can do this using some kind of program, so you don't have to actually compute all of this by hand, but it's probably worthwhile to try and do it once or twice by hand for a small number of trials just to get a feel for how the formula works.